the correlations and regression. So basically we will focus only on correlation. Next video we will move forward towards regressions. So here I will teach you about the correlation. Correlations means whether the two variables that are correlated to each other or related to each other or not. So to test it, we will perform correlation test with the help of Minitab. So in most of the cases in Lean Six Sigma, we always have some different variables that you have measured in your project. So you just wanted to, if you just wanted to check whether the two variables or more variables are related to each other or not. So you can use the correlation analysis. So the correlation analysis, we find out the correlation coefficient. There are different correlation coefficient, maybe Pearson or Spearman, and in most of the cases you will calculate the correlation coefficient, and based on the correlation coefficient, value of correlation coefficient, you will decide whether the relationship between the variable is significant or not significant. So the correlation tells us the strength of the only linear relationships between the variables. If it has some non-linear relationship like quadratic equations, like or cubic relationship or hyperbolic or any other relationship they have, it cannot tell you, right? So for only linear relationship you can use the correlations, right? So when you measure the correlation coefficient, so its values varies from -1 to 1, and if the value is 0, that means the variables are not related to each other, and if the value is positive side from 0 to 1, that means they are directly correlated. That means if I increase the value of x, the value of y will also increases. And in the negative case, if the value of correlation coefficient is negative, that means if I increase the value of x, the value of y will decreases, obviously. And -1 and 1 are the extremely cases. That's why we called it as perfect direct relationship for +1, and for -1 we called is perfect inverse relationship, right? So there are general rule, like if the correlation coefficient is greater than 0.8, or in negative case is less than 0.8, then we consider the correlation is significant. And if it is below 80%, that means below 0.8, or the value of greater than -0.8, then means we will consider it not significant, right? So we will consider three cases. So here in the case A, here if you see that if I am increasing the value of x, the value of y is decreasing. In each point, if I increasing from value of x from one point to the another point, the value of y is decreasing continuously in the same manner. So here this is the case of r is equals to -1. -1 indicates that it's a perfect negative correlation. That means if I am increasing the value of x, the same amount the value of y is decreasing. That means if I am increasing the value of x, value of y is decreasing continuously. So this is a perfect negative correlation. If we consider case B, so here I cannot interpret anything, like from first point to second point the value of y is increasing, then value of y is decreasing, then again decreasing, then increasing, then decreasing, then increasing, increasing. So you cannot conclude anything from that in this case. So here the correlation coefficient value is 0. That means there is no correlation between x and y, right? Then in this last case C, here if you see that the value of x, if I am increasing the value of x, the value of y is continuously increasing. That means there is some positive correlation, right? So this is the case of perfect positive correlation. In the next video I will perform some correlation test on that Minitab software. So the output of the Minitab software looks like this. For the first case I calculated, and the correlation between y and x comes out to 0.878. That means it's greater than 80%. That means correlation is significant between x and y, right? And if p value, so if the p value is less than 5%, then we will consider it as significant correlation, right? So in that case the p value is 0.001, that is less than 5%, less than 0.05. That means mm, correlation is significant. So in the second case the correlation comes out 0.39, that is 39%, that is very low. So this correlation is not significant, or if we can conclude from p value also, the p value is 0.264, that is 26%, that is much higher than 5%. That means the correlation coefficient is not significant, right? So thank you guys.